Yes, yes.
Okay, let me know if you're ready.
I'm ready. I'm ready.
Okay, just a second.
Okay, let me know if you're ready.
Okay, good evening, everybody. So my name is Victor, and I'm going to be your anchor for this training. So this is the Cisco CyberOps certification training. So we've been running through quite a lot of labs. We started by looking at how do we set up our machine. We looked at the Linux environment, I think yesterday. So today we're going to ride on, and we are going to talk about Wireshark and some other tools that is needed for us to understand the labs in the Cisco CyberOps training. So the live chat to be used for questions. If you have questions, you drop them on the live chat. If you are learning, indicates that you are learning. And let us have a very swift process. And I think I can hand over now to Mr. Innocent.
Hello, everyone. Good evening, good afternoon, good morning, depending on when you watch this tutorial. So this is Cisco CyberOps Associates hands-on lab. And today is day 4 of our hands-on lab. And we'll be looking at the Wireshark. We'll be looking at Wireshark in our CyberOps lab, in our CyberOps machine, virtual machine. So first of all, you need to know what Wireshark is, okay? So Wireshark is a widely used packets analyzer, okay? It's an open source network protocol analyzer. Okay, it's very, very powerful. It can allow you to capture, inspect, and analyze network traffic in real time. Okay, so Wireshark is a very, very powerful tool. So as a network engineer, as a developer, as a security personnel, security professional, your job will be to, use Wireshark to troubleshoot, troubleshoot network issues, to monitor network performances, and maybe to investigate network security incidents, okay? So Wireshark is a must-know tool for any security engineer. So in today's lab, what we'll be doing is we'll be running a script in our virtual machine. So because this is just the intro to Wireshark, there's a ready-made script already that's going to create this network you are seeing here. Let me zoom out and then widen this. You see this network here? This is just a basic network of one router, one switch, and then 4 end devices, okay? So this is a PC, this and that PC. So ultimately, these two are in different networks. So you should check up our networking tutorial on our YouTube channel to understand more about what this is, okay? So for a router, every interface in the router is a network, okay? So these two are in different networks like this. So the reason I'm explaining this network is because I'll be running a script in Python now for this lab that is going to create this virtual network for us. And then if I try to communicate with either this network between these hosts or from one host to the another host, I should be able to capture the traffic in Wireshark and then see how the how packet flows through this wire. Okay, so let me say I want to capture traffic between host 11 and host 12. Okay, I should be able to start up my Wireshark in host 11, for example, and then see how the traffic flows through this wire to host 12. Okay, so let's get started. Let me put this away, and then we should start. Give me a second. Okay, so what you want to do is to start up your virtual machine, your CyberOps workstation, and then let me look at my present working directory. We've seen all this ls. We know all this. So now I want to go to my lab support files, cd lab support files. If I press enter, I want to do ls again. I should see a scripts folder, okay? A scripts directory. So if I enter the scripts, and let me clear my screen so far, and I do ls, there is a particular script I'm interested in, okay? CyberOps topo. So let me move this away. So I want to run this CyberOps topo, okay? Because this script is going to create the virtual network I just showed you now. So let me see with ls. Now we were talking about permissions yesterday. So if I show you now and you look at this CyberOps topo here, you see that it has an execute, and that's why it's in green, okay? So you see our course is building up on the previous lectures. So if you haven't watched the previous lecture, I think you should check it out, okay? It's on our YouTube channel, so you can check out our previous streams. So now I want to run this CyberOps topo.py. It's a Python file. So if you know programming, good for you. Okay, so I'm going to run it with so we're going to use sudo and then CyberOps underscore topo.py. Okay, so these are you run an executable. Okay, and then if I press enter, it's going to ask me for my password, of course, and I'll say CyberOps, and then it launches. Okay, now this is the scripts, and then if you see here, it's showing us the topology of router 1. There's a router and there's a switch. Okay, so the H4 is connected to the router, so a separate interface in the router, while the switch is connected to another interface, which ultimately makes them in different networks. Okay, so okay, so ordinarily this won't be able to communicate unless there's like a routing protocol. So you should check out our networking class, our networking course. Okay, so let's continue. So what I want to do now is I want to assess, first of all, if I press in the help to see what this is all about. Okay, if I press in help, I will see that there are some documented commands. Okay, I can use xterm to call up on any host. So if I do xterm h1 or xterm h2, I'm going to pull up a separate window for each of these virtual machines. Let me show you what I mean. So if I do xterm h1, press enter. I'm sorry, xterm h1. This is where you should always try different options. Yeah, they are using the small letter, but be careful, okay? It's actually in capital letter. So xterm h1, because it's a Python script. Okay, so xterm h1, and then I open node h1 for the virtual network. So this is being simulated within this virtual machine itself. This is a Python script that is doing all these things for us. Okay, so this is node h1 now. I want to pull up h2 also. So call on xterm h2. Okay, and then I have node h1 and node h2. Okay, so what I want to do now is I want to see because these are different hosts. I want to see the IP addresses of these two hosts. Remember, give me a second. Okay, remember, this is what the network looks like. This is what the network looks like. This is what the network looks like, okay? So H1, H2. So they should be in the same network, of course. They should be in the same network. I mean they should have the same subnet max when I say should be in the same network. Okay. Again, check out our networking tutorial to understand your networking perfectly. So let me type in ifconfig in small caps, ifconfig, and then I'll see this for this interface. I have 10.0.0.11, and if I do ifconfig again, you see I have 10.0.0.12. Okay. So what I want to do now is I want to start Wireshark for this H1. I want to start Wireshark for this H1, and then I'll try to ping. I'll try to reach this node. So first of all, let me ping this. Let me show what ping is. So ping is used to check for live hosts in a network. So if I say I want to ping this IP address, what I'm saying is I want to check if this host is actually reachable. Okay, let me show you. If I so ping 10.0.0.12, okay, if my ping succeeds, it means this host and this host can communicate.
Okay, I think there's a little mistake there. 10.0.
10.0, okay, 10.0.0.12, okay, and if I press enter, of course I get a successful ping. So I'm just going to stop it, okay, unless it's going to continue. So I get 0 packet loss. It means it's successful. That means I can communicate with this host, okay. I can communicate with this other computer. Okay, so what I want to do now is I want to launch my Wireshark in this node and then try to see if I can reach this packet and then capture it in Wireshark and just see the ICMP packets in Wireshark. Okay, so I'm going to type in my Wireshark, and then I'm going to use the ampersand, okay, so that it runs in the background and I can still make use of this space. Okay, so my Wireshark starts and then it's asking me now, this is what Wireshark looks like. Okay, it is your first time of seeing Wireshark. So now it's asking me, oh, what interface do I want to use to capture traffic? Of course, when I did ifconfig, I saw this H1, it's a 0 interface. So I'm going to select it because it is for this actual host. Okay, so I'm going to select it, and then it is, you see, it is capturing from H1, it's H0. Okay, so now what it means now is every traffic that is flowing from this host is going to be captured in this Wireshark. Okay, so now let me try to ping node 12 again, node H2. Okay, so if I try to ping it again, remember the IP is 10.0.0.12. Let me show you what I mean. If I try to ping, let me say ping 10.0.0.12, and then you should start seeing some captures, coming in here. So keep your eyes here, and if I press enter, you should start seeing some, information popping in here. Okay, and then I think this is enough. I'm going to stop my capture for now, and then I'm going to analyze my capture. So first of all, ping uses a protocol called ICMP. Okay, ICMP. Okay. So remember, I use ping to check if a host is reachable, if a host is alive. Okay. So first of all, I see my echo requests and my echo reply. Okay. So this is ICMP, and I can analyze these packets now. So this is what a packet looks like. Okay, this ICMP protocol. And then you can see a lot of information in this Wireshark capture here. First of all, you can see the source, you can see the destination that I was trying to connect to, okay? And you can see the protocol being used. So everything, every single capture, that every single traffic flowing in through this node 1 was captured, okay? So let me now filter for ICMP, in particular ICMP in case. So most times, if you just start your capture, it will be capturing everything. Okay, but because I only sent an ICMP traffic, that's why I only seen ICMP here. Because ordinarily, when you use your computer, you make use of your web browser, you'll be seeing both SSH traffic, HTTP traffic, and other traffics like that. So there's this thing called a filter here. So you want to be able to filter for whatever protocol you are looking for, you are making use of. Okay, so if I like, I can do for HTTP, but it won't come out because there's no HTTP traffic, of course, for now. So I'm going to sync with ICMP. Okay, so this ICMP bracket, and then we can now further investigate here, and then you can see the frame that was sent, data to frame. You see the IP, Internet Protocol version 4, where this is the IP packet where you see the source and the destination. Okay, you see the DSF field, and then you see flags. So this is what Wireshark does or will do for you. Okay, you'll be able to see stuff at the lower level, at the low level. Okay, since as it flows through the wire, you are going to see it, laid bare for you. So ordinarily, you won't even see all this. You can just be using your computer and it just fly. But Wireshark, as powerful as it is, will help you to, have a deeper eye, into your traffic, into your network traffic, and what's going on in the hood, under the hood. So you can see your data, 48 bytes, and you can investigate further depending on what you are looking for. Okay. I think this particular lecture, this particular lab is just to show you the power of Wireshark, and then okay, let me just quickly try to capture between let me show you between H4 and the router too. Okay, I think that was also another option. So if I stop this capture now, I stop it, and then see it has stopped capturing, and then I can close this. Okay, I don't need to save this. So now we've captured ICMP packets. Okay, let me see. Let me open router. Let me open this router and this H4 and try to capture the traffic between these also. So let's see. So I'm going to use my XTEM again. XTEM. So ordinarily, if you don't know what XTEM is, you can use your help. You can use your help XTEM, and then you will see the usage here. Okay. If you see to show XTEM, spawn XTEM for the given nodes. So you use XTEM and the nodes. You can combine two nodes at the same time. Okay. So if I do XTEM router, what's the router again? So router 1 H4, I can write it simultaneously. Router 1 H4, and then it opens it. Let me close this one first, and then we see this for node H4, and we'll see this for router 1. At the same time, because this is a Python script, ordinarily your router, you should have your configuration for your router, but there's what they call Cisco iOS configuration for router, but this is just a Python script simulating a router. Okay. This is not what actually is in a router. You won't be able to type in Linux commands in routers. Keep that in mind. In routers, what you actually see is Cisco iOS commands. So it's totally different from Linux command. And we offer that also. So you can check up our channel to understand more about it, our networking course. So let me continue. Let me type in my ifconfig first to see the router's IP address, ifconfig, and then we should see for the router it's H1 interface. Look at the router, it's using 10.0.0.1. And then for my node H4, if I type in ifconfig again, I should see that it uses 172.16.0.40. Okay. So of course it's understandable because it's in a totally different network. Okay, so you see this, it's a 0. This is where it's connected in the router. So it's H1 is connected for the let me show you what I mean. Let me show you. There's something called interface. The place, the link where every node connects, to an intermediate device, to an intermediate device like a router or a switch. Okay, that's what we call the interface. So for this link now, for this link where this S switch connects, it's connecting using ETH1, okay, to the router. But this is the router. The router has two interfaces now, as you can see. So this is the two interface here, and then this, okay? So this one connects, this ETH2, router ETH2 connects to the router 4, while the router ETH1 connects to the, to this switch, okay? So to understand about interfaces and networks, and you need to know your networking, and we offer that, okay? So you can hit us up for further inquiries. So now we know our router's IP address 10.0.0.1, and H4 is this, okay? This is the interface. So of course I want to communicate with using this. So I can now pull up, let me try to ping this router first. So if I say ping, let me show you something, 10.0.0, let me show you first, let me see. Okay, it still works because I'm suspecting they've configured the routing protocol, okay? Because if not, two interface in the router should not be able to communicate unless there's a routing protocol that says, oh, okay, you can now communicate. Because every interface in a router is a network, all right? It doesn't work the same for a switch. Like in a switch now, all these ones can communicate easily without any routing protocol, all right? All these interfaces can communicate. This network, they can just communicate. This is one network. But with this, they're in two separate networks, even though they are connected to a switch and to a router, I mean. Because this network, this interface and this interface is the same as a different network, okay? Okay, so keep that in mind. Okay, let me start my capture again. So if I've pinged 10.0.0.1, it was reachable. So let me just start up my Wireshark here. Wireshark with my ampersand. Okay. And the same thing. Same thing. I'm going to try to capture with my H4 ETH0, and then before we move on to the next lab. So it is capturing at the moment. No traffic is coming in because this is the H4 node. Okay, so any traffic that is flowing through this H4 is going to be captured here. Okay, so let me say I want to ping. Make sure you use your ampersand, unless you won't be able to still use your terminal with it. Okay. Right now the Wireshark is running in the background. It's performing, writing some things in the background. So because of this ampersand, I can still use my terminal. So if I say ping, I want to ping this router's IP address. I can say I want to ping either this or this. Okay. And let me just ping 10.0.0.1. Okay, and then but I'm capturing, right? Yes. So let me try to ping it. And then you see more captures coming in, more packets rather coming in. You see app, you see ICMP. Okay. So I can stop it and I can say, okay, what do I want to filter for? Because ping is ICMP, okay, of course we know that already now. I can say I want to filter for ICMP, but I can also say I want to filter for app, okay, because during the course of this, app was trying to figure out who has this IP address, okay. There's something called a MAC address that is built into every single device out there. Every device out there, either your mobile phone, your what have you, your smartphone, every device has a bonding address, okay. And if before you communicate in the same network, because I told you this router has two interfaces already, making it in two different networks. So the H4 now, remember H4 has this IP address, and I'm trying to ping the router with the second IP address 10.0.0.1, making it a different network. Okay, so it has to go through app to be able to figure out which MAC address. So this is on an advanced level. You need to understand your networking to understand what app is all about. Okay, I'm just drifting here, but the point is Wireshark can expose a lot of things. Okay, a lot of packets, a lot of captures. So now I can say, okay, let me look for my app. First of all, it was asking who has this whose IP address, who has this node, this IP address, this gateway IP address. Tell 40. 40 is of course, the H4. So it's asking using app, to ask for, what is this. So after they've gone through this process, they will not end up communicating using their MAC address, okay, because they will not be in the same network, okay. Look at the address now they are using. This is what a MAC address looks like. It's different, very different from this. So this is what the MAC address looks like. This first three is the OUI, and this is the device and the identifier. So yeah, is MAC address 48 bits in length. So yeah, Wireshark can expose you to a lot of captures, a lot of packets. Okay. So okay, in the next lab, I'm going to show you the importance of Wireshark and then the importance of HTTPS over HTTP. Okay, that should be a lot of fun and then relatable to all of us. So I think we're done with this lab, this first lab. So if there are any questions, if you have any questions so far, you can let us know, as we'll be entering into the capturing packets using HTTP and HTTPS. Okay, so this is going to be a lot of fun. So you see the power of Wireshark, in real time. So any questions, you can drop it in the live chat, please.
Okay, please. So if you have any questions, you can drop it on the live chat so that we can attend to them. The persons that asked about the difference between Wireshark and Nmap, I think I've answered most of these questions, collision domain and broadcast domain. So on the playlist, you see a comprehensive content that has to do with Cisco networking, the ITN, that's the introduction to networking, and also the routing, switching, and wireless essentials. So you could run through those basics so that you can understand. The goal here is that if you're running Wireshark on the network, then you're able to do packet filtering. You're going to be able to do packet inspection. You're able to see what is happening under the hood. Now, if you want to know, okay, Mr. A is communicating with Mr. A on source IP address is going to another source IP address. And at times it's used for digital forensics in the sense that after you have captured packet for the entire day, you might not want to later get what's it called? You know, might want to now later get to understand what has happened in the network before that, because you can be capturing traffic for the entire day. Then a day or two, you can now go and kind of start off inspect what has happened the previous day. If you're able to know the source IP, of course, you know the IP address of your individual systems on your network, you cannot be able to tell where those persons went to, because you're able to see their destination IP address. Let's say if you start browsing now or accessing the website Zoom, it's going to show your own source IP address accessing the Zoom IP address. And of course, if you ping the Zoom IP address, or if you do a reverse engineering, if you try to put the Zoom IP address on whois, you're able to find and know where that particular system was going to. So that's the kind of thing you're going to see. You're going to see that in your layer 1, layer 2, layer 3. And at times you're able to see that up to, layer 2, 3, 4. And at times you're able to see that up to layer 7. Because somebody's asking the happen sign on your keyboard. So it depends on your keyboard. So it's the sign that is like the and. So it all depends on your own keyboard. So you have to look at that in your keyboard. I think you can ride on to the next lab if you don't have any other question.
Okay. So I'm just going to close this. I'm going to close this. Okay, let me stop capturing first, and then I'm going to close this. Okay, close, and I'm going to quit it. I'm going to use the command quit. Okay, and then sudo -c to clear up any mininet, process that might have been used. So use this command to clear up any processes that was used by mininet, and then just your password, CyberOps. So we are done with this first lab. So this is going to clear up any processes that was used, okay, during the course of this first lab. Okay, now let's start our second lab. Here we will be examining and HTTP traffic. Okay, so let me try to access Google. Let me see if Google is reachable. Let me ping it. Let me see. Let me know if I have internet connection in my virtual machine. Okay, yes, I have internet access in my CyberOps workstation. So I'm going to close this. I'm going to clear my screen. Okay, so I know I can access the internet from my virtual lab. So I want to pull up my web browser. Where's my browser? Web browser, and then I want to access a site. To access a site. Okay, the site is www. Oh, so okay, this is it. This is the site I want to access. This is a demo site, and it uses HTTP. Okay, no, if you look here, no SSL encryption here. So it's saying not secure. Okay, we know that already. And this is just a demo site, so it's for educational purpose. And then if you see here, this site is saying, oh, okay, let me look for the login. Okay, I can just put the / login.jsp. Okay, so this is where I'm interested in, because this is what we will be capturing our Wireshark. So now that I'm here, let me try to to start capturing traffic. Okay, and then I'm going to use another tool called TCP dump. So TCP dump is another protocol capture tool, but this time around it uses the terminal. Okay, it uses the command line. So TCP dump is you see it used in many Unix-like operating systems. Okay, the I say Unix, like I'm talking about Linux and Mac OS. So it can capture packets, can in real time, it can capture packets, and it can inspect packets also. So the command is TCP dump. So this is it. So I'm going to try to capture packets here with this command, and then save it. So you can use man to read the man page of TCP dump to see what it's all about. So for this, I'll be using some flags, some switch here. So I'll be using the interface to choose my interface, my network interface, and then I'll be using other switch here. Okay. I'll be writing it to a file also. So let me show you what I mean. Remember this man page. So if you don't know what I'm doing now, you need to check up our previous streams. Okay. So this is day 4. You need to check up 1, 2, 3 up to day 4 to catch up. Okay. And each section builds on the previous one. So if you don't watch the previous ones, you might be lost. Okay, if you're watching this now, but you can still follow along, and then later you can watch the previous ones. So let's just start. I'm going to use my sudo TCP dump, and then I'll explain this command to you. TCP dump, and then -i to choose my interface. But because I have not shown you my interface, so I'm going to pull up on that terminal, and I'm going to use ifconfig to show up my my interface and everything else. So I want to use this interface ENS34, because this is where my IP address is. So this is my private IP address. Okay. So I'm going to use this interface ENS34. So I'm going to say ENS34. So yours might be different. It's just something like ENSP0S. So it depends. Okay. Just make sure you confirm your interface. Okay. So ENS34-S0, and then I'm going to write it to a file called http dump.pcap. So pcap is the extension for packet capture. Okay. So I'll be able to now open this captured packets in Wireshark to further see all the things that have gone through this interface. So I'm going to press enter now to start capturing my packets. So it's going to ask me for my password. So I'm going to say CyberOps. And then you see here it's saying it's listening on ENS 34. Okay. And then it is capturing some traffic now. So what I want to do is I'm going to refresh this page. Okay, I'm going to refresh this and then it loads. So what I want to do now is let me open this, let me enlarge this. What I'm doing now is I want to type in a username and a password. So this is typically what happens in a man-in-the-middle attack, for example, where somebody, an intruder or a cyber criminal gain access to your network and then is capturing every traffic flowing through your router. Okay, so what the hacker or the black hat has done is he has convinced your router that is you, okay, and then convinced you that is the router. So any information, any information you send to the router will be captured, and any information that the router sends to, send back to you, the hacker will also capture it. So let me now try to log in here. So it's going to be, let me say I'm logging in as admin, and then I'll say my password is, my password is my secure. Let me not tell you because I don't want to tell my password, of course, but of course, we're still going to see all this in clear text. That is why they always tell you that you should use HTTPS instead of HTTP, okay? You should not sign into any, unsecure, network or connection. So let me log in here, and you still get this login error message that, oh, it failed. Of course, I need it's going to fail because this is not, we're not signing or anything. So let me not clear out of this and stop my capture. Okay, so I'm going to just press Ctrl C. Remember the name HTTP dump.pickup. So I'm going to stop it. And then you see we've captured some packets here. We've captured some packets. And then if I clear the screen and I do ls-l HTTP, this, we see this, this is our file here. And then this is what it looks like. So what I want to do now is I want to say Wireshark, okay, HTTP dump.pickup, and then press enter. And then it's going to open it automatically. Okay, it's going to open the file. And then we'll see that with a lot of traffic has been captured, okay, from DNS to ICMP to TCP connections. So a lot of traffic has been captured. So what I'm doing now, I'm going to use this filter tab to filter for a particular protocol. So I'm going to filter for HTTP. Excuse me, so I'm going to filter for HTTP, and then I'll press enter. So now we see all this HTTP traffic. So this is HTTP, this is our captured packets. Now I want to find this my login page, this sign-in page. I want to locate it. I want to know which packet it is. But of course, because I know my web programming, because that is why Mr. Victor will always tell you you should understand your concepts, should understand web programming, should understand at the basic level what's going on. Okay, so because I understand my web programming and I know if you are sending in data, okay, it's going to appear as a post, not a get. So it's going to appear as a post request, and I can scroll down now and look for posts, amongst all these many packets. And then so yeah, I've seen posts, and then I know this is it, and I can click it, and then I can do more things. So let me show you what I mean. So I can now come down here and say, oh, what am I looking for? HTTP form, just with this, and I can see this in clear text. I can see my UID, my user ID as admin, and then my password as my secure password. So this is the reason why HTTP is very, very, very unsecure. Okay, so this is the reason the HTTPS was introduced. So because your data can be in clear text. If a man captures your traffic, if a man in the middle captures your traffic, this is the reason why HTTPS was introduced. So now we're going to try to, log into an HTTPS website and see what happens, in comparison to this. So let me close this. Now you've seen the reason why HTTP is not secure. So let me close this and then try to locate any login page for HTTPS. I can use, for example, Facebook login and press enter. Let's see if it opens, please. Don't waste our time. Okay. Oh, I can try something else. Netsacard.com. Let's see which one opens first. I'm betting on this. Okay, Facebook. Okay, you would have eaten my money now, but hey, I don't bet, so good news. So let's see this. Login. Let's see what actually happens. Okay, this is loading. Give it time. So this is a virtual machine. So the traffic, my internet access is being shared to this virtual machine. So it won't be as fast as my normal live one. So it is opening. Okay. Okay. Give it time. I think the internet connection is a bit bad today. So finally it's open. What I want to do now is I want to use my Opera Rookie to locate my previous command, and then I'm going to change this name to HTTPS dump, and then I'll start capturing. Okay. I'll put in my password, CyberOps, and then I'm listening for connection. I want to do now is I want to refresh this, and repeat the entire process, and then it has refreshed, and I want to put in my username and my password. So for example, Celtech, if I can type my @, please, where are you? At let me say gmail.com. Of course, it's not our email, and then I'll say, hey, okay. Oh, a very, very long and secret password, of course. What do you know? That cannot be, captured or hacked, right? So we try to log in, and then okay, this is not us. So of course, so we're done with this. I can now close this, Ctrl+C, and then I get all this. Again, I'm going to open my Wireshark and then say HTTPS this.com, and then we get all this, okay, all these packets. So let me try to filter for HTTPS. HTTP, does that work? I think HTTP, okay. HTTP, okay, see HTTP, and then let's see if there is any specific data. Okay. HTTP. To see if there's an HTTP.post in this filter data. Let's see. Okay, because you need to see your captured file, your captured data. So HTTP, but no. Okay.
What if you try to filter port, what was it called? 443.
443, okay. Let's do that.
As in TCP.port.
TCP.port, yeah. TCP.
Double equals 443.
TCP. Okay.
No, as
This
in
doesn't work. Dot port double equals. Let me use it in small caps. TCP
TCP dot port
dot port
double
double
equals
equals. Yeah. Okay.
port
Okay. Dot port. If I can type
double
equals
equals
443. Okay. So this is why you should know your protocol also. So now we see this. Let me see if we can get. Let's see if we can get TCP 443. Okay. We are seeing some 443 here.
Yes, that's 1443 there.
Hello. Okay, but I'm looking for HTTP if it's going to show. Okay, it's not in here yet. Let's see. TCP. Okay. So sometimes it can be this.
Let's see if we can search, if we can see an acknowledged or a 200 status. That's
Status.
443.
Okay. Okay. Let's see.
We'll also try to check at the very end.
Yeah. No. No.
Okay, let's check the documentation then.
Mm.
No, I mean the lab guy.
The lab. Okay.
Okay.
They use what is it called? Cisco packet tracer. NetAcad. I mean, it's NetAcad. I don't know if it has to do with the sites.
No, it doesn't. Let's just see the filter.
Okay. Okay.
They've collected the
They
file.
use the 443 option.
Yeah, TCP port equals 443.
Okay.
I think the very first one,
Application
data.
So let's I think we've seen application data here.
We have a lot of application data.
So let's pull up the document again and see. Okay. Okay, so now let's see if we find an SSL. Okay, let's look for an SSL for the security in the HTTP. Okay, so let's see if we find SSL, because that's what you should be looking at in the TCP connection. So let's see SSL. Okay, this time around, where is the application data? Application data. Transport layer security, this is SSL. TLS, SSL. Let's see if any of this. Okay, of course. Encrypted. Okay. This is encrypted. So we're going to be seeing some encryption. Okay, it won't be in clear text. So of course, you can still continue to go to poke around, but your passwords will just be in clear text, because this is HTTPS. Okay. So instead of TLS, you can still keep going for looking for SSL. If you to see if you can coin any data out of the garbage, but you won't just see anything because it will be encrypted. Okay. So this is the power of HTTPS over HTTP. That security there, that S in front. So so yeah, yes, this is it. So I don't know if there are any questions so far. You can keep going and poking around. You won't see any clear text password because it is encrypted. It is HTTPS, not HTTP. Okay, so it means it is actually secured. Okay, so unless maybe there's a way you can, because if you're the man in the middle, there's what you can do. You can strip the SSL out of the but that is an advanced option. It's what they call SSL strip. So you have to strip the SSL before you can be able to even capture any data here. So yeah, so that's the power of HTTPS over HTTP, where you can just get your passwords in clear text. Okay, clear text. So any question in this particular lab? Because this was actually fun because I enjoyed capturing my own password in clear text. I wonder
Okay,
how to make that mistake.
somebody's asking, okay, the lab guide. So you already have the lab guide. If you check southernventures.com/cyberops, you see the lab guides are already there, so you can download them. Somebody's asking that, is that hashing? Yes. So hashing is a form of encryption. So that data is encrypted. So somebody now asks, if the bad guy captures the password, is there a way to decrypt the encrypted password? Yes. But the thing is that most passwords are not encrypted in a very straightforward sense. So there's what to call ciphertext. So that's cryptography. I think in one of the modules, you have cryptography as a module. So you have different forms of cryptography. So it is possible, but it's always a very long route. Take, for instance, now this packet that was captured was Facebook. Of course, Facebook is not just going to do a one-way encryption. So, but in cybersecurity, we normally say there is nothing that is not possible. So the road for you to decrypt a particular password is always a very, very long road. But it's not that it's not possible. So in encryption, you're going to say plain text, ciphertext. Plain text is ABCD. Then the ciphertext of that plain text is going to be 125A 5235 forever. Now the question is that when you are doing encryption, you just have a formula that tells you that you substitute whatever you have here into that formula, then you now get the ciphertext. But most of the times in advanced way encryption is not done, you cannot just reverse engineering in a straightforward sense. So there's what we call password salting, peppering, and hashing, and several other advanced methods to like encrypt, so that you cannot just pick this decrypted item now and go back, right? So that's not about what's it called, password encryption, decrypted. Somebody now said, okay, please, can we get the guide as well? They should already have the guide. I don't know. Most of us are not actually paying attention to the information we already have. The lab guides, you already have them. Ijamana said, I'm suspecting your question. Okay, I think that will be all for this lab. So I think you can move to the very last lab for today.
Okay,
so on the group, I'm going to drop a guide that is going to help us on interpreting whatever you're going to capture on Wireshark, also interpreting the color codes, because somebody was asking the different color code. I said if you have TCP, it's going to be light blue or green. Then if you have an error message while you're trying to collect your packets, or you had a port number or a website that was not going through, or you had an error in connection, it's going to show red. So I'm just going to drop the different color codes so that you can familiarize yourself with interpreting the colors and be able to do different types of filtering. Okay, I think in the absence of more questions, we'll just move to the next lab.
Okay, let's move on. Let's continue. So we are done with this. So we've seen the importance of HTTPS, over HTTP. So this is this. So let me close this and then close this capture. Okay, I can actually remove HTTP if I can type on my keyboard. Shifts is if I can actually type. Okay, I'm just move it on manually. HTTPS down manually, sorry, because I used sudo. I can't remove it as an ordinary user. So, and then I'm going to remove the HTTP also. Okay, so I'm done cleaning out. Okay, so now we are going to examine, we're going to capture telnets and SSH traffic. So I explained SSH in our previous lab. So what is SSH? What is telnet? So they are both remote login protocols. So they will allow you remote access, to a host machine. So the only difference is that SSH is a very secure way of logging in remotely, while telnet is not so secure. Okay, and then the ports, SSH uses port 22, while telnet uses port 23. Okay, so I'm going to start up my Wireshark capture again, and then let me use ampersand. Okay, press enter, and then it starts. So what I want to do is I want to start capturing in my loopback, in my loopback interface, my local host. So if I double click here, it starts capturing. Okay, it's capturing from loopback 00. So if I try to ping, it's going to capture. If anything I do, any connection that has been made here in this machine is going to be captured in Wireshark. So let me say, for example, I want to log in remotely to a remote login section. Let me say my remote login section should be, let me say, my local issues is localhost, for example. I know you'll be asking, how is it possible to log in to my localhost? Well, that's telnet for you. I'm just testing this. But ordinarily, you won't want to be logging in to your localhost because I already have access to the local machine. But I'm just, trying to initiate this telnet, capture, and then I'm going to start seeing traffic here also. So let me just press enter, and then it's saying connected to local hosts. Okay, if I press enter again, let's see. Hopefully, I think I'm waiting for anything. Let me type in a random character and see. Okay, it should show me my. It should prompt me for my username and my password. So let's see. Let's see. Give it time. Give it time. Okay, let me see Control C, and then nothing happens. Give it time. Okay. Okay. Now this is okay. This section is not giving the appropriate feedback. So let me just close it and restart it over again. But this is going to close also, so I'm not worried about that. So let me just close out this. Close window, and then let's redo this. So do this Wireshark %, and then loopback interface capture. It's capturing. Let me try telnet again. Telnet localhost. Okay, let's see. Now it's okay. If I type in analyst, it's supposed to ask me for my login section. Since this doesn't work, let me use. And the funny thing is, I can't, move out of this. Give it time. Okay. Okay. Check this. Clear. If I say telnet here in this environment, and I say 127.0.0.1. So all my data is being captured here. So this is Wireshark in action. But nothing is, It's not giving me my feedback. Okay. Control Shift 6. It's in Cisco. Okay. Close. Hold on. So, internet localhost. Give me a second to troubleshoot this. Okay.
Don't forget, if you have a question, you can, while he's trying to
drop
that, you can drop your question if you have any question. We're trying to look at Wireshark. How do you use Wireshark to do filtering, to do inspection? I'm able to even do post incident response only if you have captured data before the time you're not doing inspection. So if you have Wireshark, you can also install Wireshark on Windows. If you're running a Windows system, you can install Wireshark on Windows. You don't need to set up a lab to implement Wireshark. Just a second, let me see if I can drop that. Download Wireshark.
Yes.
Just a moment. While he's trying to troubleshoot that. So you can install Wireshark on Windows. You can install Wireshark on Mac. You can install Wireshark on even portable Windows machine and also on Mac. So I'll just drop the download link so you don't need to set up a lab. If you already have Kali Linux, you can also implement Wireshark. You don't need to virtualize to set up this. So I'll just drop that in the group. So somebody's asking, is there any difference between Nmap and Wireshark? I think I've already explained that. So Nmap is a network mapper, topology mapper. So you have different types of network in your basic networking. Please check the channel. You see a comprehensive video on network, the different aspects of the network, connecting media, connecting device, then the different topologies we have on a network. So a network can be a star topology, can be a bus topology, can be a ring topology, can be whatever kind of topology. So when you're using Nmap, you're trying to plot and see how your network is laid out, right? So you just want to, because if in reconnaissance stage and scanning, once you understand how your network is laid out, that can now be able to help you better plan your attack. That can be able to better plan and understand your IT infrastructure. That's the advantage of a network mapper. So it's completely different from whatever you have in, what's it called? In Wireshark. So Wireshark is for packet filtering. It's for packet inspection. It's completely different. So the GUI interface of, what was it called? Of Wireshark is called ZenMap. I've just dropped that in the training group. So you call that ZenMap. Whereas if you are running the CLI interface, you call it Nmap.
Okay.
So I think, are you ready now?
Yes, I'm good to go. So this is the reason why I have two virtual machines, two virtual environments. So it's also the reason why we do things like this live and try to troubleshoot it. So you see, my VMware was my virtual VMware workstation was giving me issues. I had to pull up my virtual box and then it's working perfectly. So let me close this. Let me clear my screen and then execute Wireshark for this lab and then use the ampersand. If I can type, okay. And then Wireshark should open and then we'll select my loopback interface. And then you see this running, okay. And then let me try to execute telnets on my local hosts. And then we see some captured data here. And then I can put in my password, of course, analyst, and my username. analyst, and password, CyberOps. Okay, press enter, and then we say, oh, last login, so and so. That's it. So from this IP address. So now this has been done. Let me now examine my Wireshark to see what has happened. Okay. So remember we use Telnet. So Telnet is a remote login protocol. So let me filter for Telnet and then I'll see what's happened. So I'm getting Telnet data. This is this. So let me start with this first capture here. And then I'll say, oh, Telnet, this is Telnet protocol. And let me see what I have. Okay, first of all, I want to right click on this and say follow follow TCP stream. Okay, this is it here. Follow TCP stream. And then I'll get this. This is it in actual clear text. So we can see, oh, look at my username here, analyst, and this is my password. So the reason you are getting this double is the way it was echoing back our password to us. Because if you see when I was typing it, it was actually showing it here, and then it was still recording it in the background. So for every character, it was saving it to the protocol and outputting it. That's why we get it double here. If you look here, that's what we're seeing. AANN, AALL. So this is it being echoed back to us. At least we know what echo is. So so yeah, this is Telnet in clear text. And now I'm going to try the same for SSH. Okay, so I'm going to close this. I'm going to okay, it's still being captured. So of course it's okay. I can just filter it. See, it's still capturing. So let me just allow it. And I will just type in SSH localhost. Okay, and I press enter. And then we'll say oh, fingerprint, I actually want to continue connection. I'll say yes. And then to ask me for my password. Okay, I'm going to type in my password again. CyberOps, press enter. And then last login on Tuesday, so and so. So let me see if I can pick it up for SSH. SSH, press enter, and then we get all these SSH connections here. So now let's see what's actually happened here. So let's try for this first one and say SSH follow TCP stream, and then instead of getting our latest password, we're getting a bunch of gibberish. You won't even see it in clear text. It's not possible because SSH uses a very, very strong encryption algorithm. Okay, so so yeah, we've seen HTTPS over HTTP, and then we've also seen SSH now over Telnet. So now you understand the reason for encryption, the importance of staying secure and all that. So yes, this is a good way to to prove that point. So in case you are logging to any website and it's in clear text, remember, and it uses HTTP rather. Remember, the website on its own is not vulnerable like that just by using HTTP. Where your vulnerability comes in is when maybe somebody is listening for your traffic, for your traffic, in real time. Maybe there's a man in the middle in your connection. They're just a guy with a laptop, passing around your compound and then sniffing your packets, to your router. Then whatever you type in now can now be captured, and then you can go back home and then you'll be smiling, grinning, having done such a good deed. So guys, this is the reason you need to stay safe, log in wisely. Okay, log in wisely. So I think this is it for today's lab. Any further questions, you can bring it up, please. Thank you.
Okay, thank you very much, Innocent. Let me know if you have questions on the live chat. You can drop your questions. Let's attend to them before we revert back to the training group. Let me know if you have questions. Two minutes for questions. 2 minutes for questions. If you have questions, let me know. Okay, somebody's still repeating the same question, and I think I've answered that question. Okay, so in the absence of questions, we're going to call it a day. So see you guys in the training group for our review before. That will be the end of day 2.
Day 4.
Sorry. That will be the end of day 4. Okay, thank you very much. And see you in the training group for review.